Thank you. It's a bit difficult to have this presentation after Nicholas won because it's so brilliant, and I mean, these design guys, the slides and the videos and all these fancy things. I mean, I'm a software guy. I cannot do this. So please be ready to be a bit bored compared to how you've been with Nicholas. Just a few words about the template. You know, the slide template is very red. This is not communist. This is
Stanford, right?
Oh, it could be Stanford, indeed. But no, it's, you know, CA has completely changed its communication recently, and I don't know why they've chosen this red thing, which apparently is supposed to mean that we are dealing with energy, so energy, red fire, and this kind of stuff. But this is definitely not communist. Even for people who know, CA was at the beginning led by people who are very close to the Communist Party, by the way. It was long ago. So I'm going to talk about the Resilient project. It's a European project dealing with energy management at district level. So first, I would like to answer a question asked by Jean-Claude at the beginning. Jean-Claude, you asked, is there an added value in smart cities? Yes. Yes, definitely. And we are doing ICT in our department, and we definitely think that there is an added value in bringing some more ICTs, some more smartness in cities. So, a few facts and figures about this project. So, it's a European collaborative applied research project. In Europe, research is funded in several successive funding periods called, until now at least, framework programs. So this project is funded as part of the 7th one, which is ending soon, and which will be replaced by one called Horizon 2020. Everything is 20 in Europe, basically 20%, and Horizon 2020 and so on. So more specifically, this project is funded as part of the Energy Efficient Building Public-Private Partnership. This is a bit specific. This is why I mention it, because these PPPs fund very applied research projects which are supposed to produce results that have short to mid-term potential for transfer to market, right? And for your information, it was funded as part of this PPP was started as part of the economic recovery plan, and it represents 1 billion euros funding on a 5 years period. Resilient stands for, you know what resilient means, I guess. But in the scope of this project, it's an acronym, and you have to be very good at devising acronyms when you work in a European project, as you can see. I'm the one who devised this one, and I'm pretty proud of it. So it stands for coupling renewables, storage, and ICTs for low carbon intelligent energy management at district level. It's quite a large project. I mean, at least at the European scale. I don't know about the US. It involves 14 partners from 5 European countries. It has a budget of 9 million euros with a 5 million euros EU contribution, and a quite long duration of 4 years. This is because we have a lot of demonstration activities in the scope of the project. And I think this would... Michel, you said that systemic approaches were necessary, and you also said that demonstrators are critical. So I hope you'll enjoy this project. The base rationale is another quotation from, it was from Arshad, no, not this one. I'm sorry, I'm looking for my notes. I'm writing so bad, I cannot see. Oh, I think I forgot it. Nevertheless. Well, yes, resilience is also the ability to cope, right? This was what he said, the ability to cope, so to react to unexpected situation and to have some kind of emerging behavior that enables the system to react properly and to survive and to recover, right? So we think that for a city, the best way to do this is to divide it, basically. in districts. So we think that one way to deal with resilience, at least from the energy point of view, is to focus on the district scale and to work on this integration of microgrids, renewables, storage facilities with a lot of ICTs, because we love deploying ICTs in districts. So this is the main objective. This project is focused mainly on energy. So what we want to do is to decrease energy consumption at a district-related level. So the figure is again 20%. As you can see, it's always 20. It's very simple. And 20% of energy demand decrease of all buildings collected compared to what it was when the buildings were operating separately. And the same goes for the CO2 emission reference level. And to do this, we want to achieve local optimization, which means matching local demand to local supply. Also to achieve an overall balance in all energy flows, which means also dealing with multiple energy carriers. And in our scope, it's to deal jointly with the electricity network and district heating network. And the challenges in the project are that it's a very demo-intensive project. We have 3 million euros dedicated to these demonstration activities in 3 demo sites in Europe. We have very heterogeneous energy production to deal with, including cogeneration, which can be very tricky. And we also aim at having some innovation as regards storage, especially for heat storage, as I will show later. And the concept is to rely on this combination of microgrid and energy hub concept. So basically an energy hub is this kind of thing. You have some one or several energy carriers which are going in, and one or several other energy carriers going out. And to deal with all these issues, having, in an analogy to what is done in the building domain, some kind of district energy management system, and which can support both planning and operation activities. Regarding optimization at planning phase. So planning, basically, you have one district and you want to optimize it in some way from the energy perspective. So what people do usually, and this is what they do, for instance, for buildings, they have some kind of simulation tools in which you can test various configurations of your building, the energy systems that could be deployed, and so on. And then you can see what is the best configuration to choose. And what I want to do is to do the same at the district level. Basically, there are a lot of tools which enable simulations in every kind of physical issues you could consider. But here, there are 2 challenges. One is that we do not have the physical digital models that enable us to have a holistic simulation of the various systems, networks, buildings, and so on, that are part of the district. And another challenge is also that we do not have one simulation platform which could enable us to have this holistic simulation. So we have to connect the tools together. And for those who have tried to connect a simulation tool, I guess they know it's very, very intricate. Right? Regarding operation, basically the idea is to be able to monitor and manage the district. So this is basically full of ICT. The main challenges are to deal with data, so this data tsunami that was mentioned during the first presentations. Building from this data some knowledge that can be used to understand how the district is behaving, how is it used. So this is this district information model we are working on. And you also have to deal with distribution. Districts are very heavily distributed and heavily hierarchical systems, and you have to rely on a paradigm which enables to deal with these issues. And this is why we rely on the agent-based multi-agent systems paradigm to deal with this distribution and having all these intelligent agents that are able to collect to monitor and to control all the systems deployed. Also, one issue is to be able to have a lifelong storage of the data in order to be able to have some kind of history, in order to be able to assess the behavior of your district as a district manager, and to be able to improve it based on this history. So we plan to have this platform, storage and high-performance computing platform, in order to support this issue. And the two last components are expert systems, which bring some smartness in the system. They support the agents, basically, and simulation, also to have some kind of prediction of the behavior of the district. The difference here, compared to what was presented in the previous slide, is that simulation here has to be almost interactive, almost real-time. So this is why we need this high-performance computing platform. So you see, in the end, this is a big toy, a big ICT guide toy that we are going to deploy in 3 wonderful sites in Europe. I mean, wonderful from the demonstration point of view, not forcibly from the landscape point of view, because we have one in Belgium. Nothing against Belgium, but it's just
yes,
that it's not so.
Belgium.
Okay, great. I love Belgium. Okay, so this one is nice. What is nice is that we have 3 very different sites. This one is only a residential area, 66 social housing dwellings with a central cogeneration unit and some individual thermal storage and thermal solar panels. So this is the smallest one. Then a university campus. This one is quite fine because, again, we have very different buildings: educational buildings, offices, laboratory, restaurants, sport facilities, library. And what is really nice is that in this campus, as part of another project they are deploying right now very nice and advanced energy production facilities, photovoltaics, concentrated solar power, microwave turbines, and they have also electrical storage systems that are going to be deployed as part of Resilient. And last, but as usual not least, so this word on the left is a real one. I mean EBBW. This is Welsh, right? And Welsh, so it's a part of the UK, and it's basically it's in the southwest of UK, and they have this Welsh language, which is quite fine. The first time I saw it, I thought someone had slept on the keyboard and that, you know, randomly letters that. By the way, they're very nice. And so they have this major regeneration project in Wales, which represents a very big budget, like £200 million. And in the scope of Resilient, we are specifically targeting 6 buildings, which are again very different. What is nice is that they have an energy center, which is the home of this cogeneration unit based on biomass and gas. And they are the ones who are going to manage it. I mean, the city council is the one who is managing this energy center. And this is quite fine because usually we have so many difficulties to gather all the stakeholders. So in this case, it's much more simple. And they have a lot of things like PV panels, thermal solar panels, electric vehicles, and really wonderful underground thermal storage, which is really scarce. I mean, they have large-scale underground thermal storage. This is because it used to be a site for the steel industry, and they have very big, facilities, building concrete, like tanks, building concrete, and we are going to rely on this to adapt them to have these underground thermal storage facilities. Well, so these are only intents, right? These are not results. So all I can say is see you in 4 years, or a little bit earlier, like in 2 or 3 years, with the first results. I will be glad to present them to you. Thank you so much.
Any questions for Sylvain?
Yes.
Hi, Sylvain.
Hi.
You know, in all the 4 projects that you mentioned, you had a boundary for each project. Okay. Have you ever tried to look at increasing the size of the boundary or decreasing the size of the boundary, and how it affects the final results? When I say, you know, each site has a physical boundary.
Yes. That's,
Okay.
Yeah.
So, what happens if you increase the size of the boundary? In other words, you include other things in the boundary, or if you decrease it, do your results change dramatically?
Yeah, clearly. I mean, I hope I did get your point, but basically you're asking when the black box is beginning, right? Okay. So in the scope of the district, basically the black box is the building, right? We are considering all these systems that are deployed and all the loads in the district as black boxes with which we will have some kind of interfaces which enable the district management system to have the information it needs to perform the monitoring and management, and basically for this black box to have the information it needs from the more global ecosystem it's embedded in, right? And so if you enlarge again the scale, you go at the city scale, for instance, basically you could consider that it's the same. You could have some kind of network in which you have those black boxes which could be district. It's a very schematic view, but it's directional, right?
Okay, thank you very much.
Thank you.